Okay, so last time we talked about using references and returning references, and we said that returning references is something that we do with the operator overloading. Usually it is not done much, but it is used from time to time, and we need to know how it works. This is not the same thing as, okay. Let me load everything here. All the CPP programs. Okay, so we said that returning a reference is something that we do from time to time, and the last example that I showed you, this example is about returning a reference to a element in your object. So with this one, I said that there are two ways to return a reference: a constant reference and a non-constant reference. If I return a non-constant reference like line 14, I can use it as an L value like line 25. So line 25 uses line 14, and in this case line 28 and 29 uses line 13, okay, because for those are not L values, so those are R values, okay. So the compiler is smart enough to call the appropriate one, the suitable one. If it is an L value, then it calls this one. If it's an R value, it calls this one. Okay, good. So question for you. If I remove this const, in this program, okay, what would happen? Where would I get the error message? There would be an error message. Where would I get the error message? I remove this car from the constant function, okay, and in my main, or in my, I remove this too. Where would I get the error message if I compile this program? So there was a car and I removed it. What?
Maybe 23.
I don't hear you at all.
23.
Say it louder.
23. Maybe.
23 says that, why? 23 doesn't talk about an index operator. This is a function call. Anybody from the Teams audience?
Yes, I see it. Maybe 25.
25. When you say 25, you are saying, but I mean, why do you think that 25 will call line 13? It would call line 14, right?
Yes, sorry.
First of all, let me ask you this then. I mean, is this an error? Will I get an error message? Would I get an error message for this?
You cannot make assignment to const chart pair object, I think we don't get error message.
You are saying that this would compile if I don't, this would compile, you are saying if I don't call anything like this, main is just empty, right?
Yes.
So is that true? Does everybody agree with this? If I don't make any calls, this wouldn't produce any error messages. No, the answer is not. Answer is not that you will get an error message. Error message is going to be at this position here. This one says that I am a constant function. I am not going to modify anything, but it is returning a non-const reference. So whatever I am returning can be modified. So this function this function won't compile. At this line or this line, it says that you are returning a non-const reference from a const function. You are not allowed to do that. And in fact, let me compile this. And if I compile it, where is my compiling? Okay. It gave an error message. I can see the error message, but it is important to know the error message. How did I get the window again? The error message window. Tools. Not that window, not that. Tools, compiler, environment, editor, package, execute, view, maybe. Yeah, search. Yeah, report window. Yeah, here is the report window. Report window says that at line 50, invalid initialization of a reference of type character reference from an expression of type constant character. Okay, so it's a constant character. First is a constant character. Why? Because this function says that I am going to work on constant objects. Okay, I will consider my object as a constant object. So this is a constant character, but I am returning a non-const character. Okay, so I have to put this const back. Okay, put this const back. Now this will compile. How about this? Would this compile if I put a constant here? As it is, would it compile?
Yes.
Why? Because
I get non-const value, but I return. I say the compiler.
yeah.
If I return this value, I didn't
Uh-huh.
change this.
I am going to return this as a. As a constant character reference, so you can't modify it, but it is up to me whether I would return a non-const or const, because I'm not saying that I will work on const objects. But it will work this case, yes, that's true. Let me try to compile it, will compile, okay. What is this? Okay, I didn't say constant here. Okay, compile, it will compile. Okay, but the thing is that my main function, how am I going to remove all those command statements? Is there any way to do it fast? View, edit, command, uncomment, yeah. This one, yeah, okay, good. So, would it compile now? Would this one compile? First of all, these two have different signatures, right? One of them is a constant function, the other one is a non-constant function. They have different signatures. Yeah. So there won't be any, you are defining the same signature function error. But the problem is going to be something else, I guess. This will not compile now because what? Because of line what? 25, because 25 says that, okay, I need to use the index operator, either this one or this one. Okay, A is a non-const character pair, so I'm going to call this one, but this one returns a const connector reference. So what does that mean? it means that since this is a const character reference, it cannot be an L value, so I will get an error message here. Okay? So the error message says assignment of read-only location. Okay? So, I mean, I told you this many times before. Try to do these kind of experiments. What happens if I do this? What happens if I do that? And you will realize that either you didn't understand something right, or there is a better way of understanding it by looking at the error message. Why am I getting this error message? Why am I getting this error message while I am using this, and etc. That will make you understand things a lot better. Okay, let's go back to the slides again. We talked about this again, returning a reference. I forgot to tell you something. Of course, when you are returning a reference, from a function like that, of course the reference, whatever the reference you are returning, okay, it should be alive after the function is done. For example, this is a very bad code. Very bad code means it compiles, it runs, okay. Sometimes it looks like it is working. Sometimes it looks like doesn't make any sense, and sometimes it crashes. I have a function f, okay, it doesn't take any parameters. It has a local integer I, and I promise to the outside world that I am going to return a reference to an integer. This is a very bad code. Why? Because I am returning a reference to something that is going to die soon, right? As soon as I make a function call, and it would be okay if you say f gets the value of 17. I can write this would compile, this would run. Most of the time it runs. Sometimes it crashes, okay? But don't expect out of anything good out of it, because there is a logical error. Why? Because as soon as this function f is done, I is deleted, right? I don't have this local variable anymore, okay? So 17 is assigned to some place that doesn't make any sense, okay? We don't have this problem in our case. Why? Because in our case, the assignment that I am doing with this reference is my object's character first, right? This one, my object's character first. So after line 25, my object A is still alive. So whatever I have inside it, that part is alive too. Okay? So be careful about returning a pointer from a function or returning a reference from a function. You always have to be careful in terms of what would happen after the function. Would it be dangerous to return such a thing? I mean, if you remember from C, if a function returns a pointer, do you know what is the most commonly used function that returns a pointer in C? You have used it many times. A function that returns a pointer. Malloc, right? Memory allocation stuff. It returns a pointer to the newly allocated space. It definitely knows that space is in the heap, and after the function ends, that space still belongs to you. That's fine. Okay, that's good. Or other C string search functions. C string search functions. Okay. str, it should return a pointer to the position that it finds it. Okay. This one returns a pointer to the character where this S2 occurs inside S1, right? So after this function call, I definitely know that both S1 and S2 will be still alive because you sent them to me, right? I didn't create them. So this is important to know. I mean, if you are returning a pointer or a reference from a function, you should definitely know that after the function call, that object is still alive, and in this case, no problems. But this is a bad example. Yeah, I am returning a reference to an object that will die as soon as this function ends. Similarly, if I do the same thing with a reference, or if I do the same thing with a pointer, it will do exactly the same thing. Okay, let's say this is a pointer, function name G, okay, integer I, and I am returning a pointer, address of I. Okay, so this is as bad as this one, pointing a reference or same thing. Okay, so without forgetting that one, I go back to the slides again, and let's talk about this stream insertion and extraction operations. Okay, so for the stream insertion and extraction, let's look at this stream insertion operator. So what do? I say cout. Okay, and let's say I have a money object M1. When I say this, compiler will say, okay, you are doing either a operator stream insertion, okay, cout, comma M1, or cout dot operator M1. Okay, that's the meaning of it, this, right? We say that this one is out of picture now. I mean, this one is out of question. I can't do that. I can't overload this because I cannot go into the class of cout and modify that class so that it has a new operator stream insertion function. I can't do that. So this is not an option. That's not an option anymore, okay, for this case. So the only thing that I can do is this one. That means that I have to write a global function, right? I have to write a global function. So let's try to write that global function. The name of the global function is definitely going to be operator stream insertion. And the first parameter is the parameter of cout. It is, I will tell you, it is O stream, object stream, output stream, sorry. O stream, and since it's a large object, it's an object, I take it as a reference, and let's call it out. And then I am going to send my money object, so second parameter should be a money reference M. That's it. Okay, that's it. Since this is a global function, I don't put a constant yet because it's a global function. So what do I do now? Oh, okay, return type. We are going to talk about return type. It should return something, otherwise I should say void or something like that. But yeah, since stream insertion will not modify this money object, I should put a constant here. Okay. How about this one? Should I put a const in front of it? We don't know. Actually, we don't know how this stream insertion works. But I will tell you, no, you don't put a const in front of it because we will modify your output stream object because we are writing into it, right? This output stream, this out remembers my cursor, where the cursor is, okay? When you write it, it advances the cursor. So you change this object out when you use the stream insertion operator. So you don't send it as a const. I definitely know that money will not be modified, so it is a const. How about this return? Okay, so to understand what the operator stream insertion should return, maybe we can do this. We know that this one, M1 plus M2 should work, right? So I'm going to write the money one first, $5.70 plus $3.30, right? This one should work. So if this one is going to work, then let's look at this part. What is this? This one should return exactly the same cout object, so that I would read this as cout stream insertion plus, and again this one should return and the same cout object, so that I can execute the rest of the stream insertion. Okay, this is called cascaded operator calls, and we have been doing this all along. When we say 1 plus 2 plus 7, we are doing the same thing, cascading. So this one should return an O stream, but we are going to return a reference from it. Why? Because I am going to return exactly the same object, the object that I get in, and I am returning it, and I am returning as a reference, so there is no copying involved, and I am returning exactly the same object that I received. So this should be how the interface of the how the declaration of the function be. Let's talk about the stream extraction operator. Exact same thing operator does. This time CN, the type of CN is iStream. Again, reference input, and I should send a money reference M. This time this won't be a constant. Why? Because stream extraction will modify the object M. So I am going to return exactly the same thing. iStream will be returned. Okay. So the first thing, this is out of question. I can't do that. So unfortunately, I have to overload this with a global. We are not talking about global would be nice. We are not talking about global would eliminate many function overloads, because it will do this automatic constructor calls and etc. We are talking about we can't do it. It has to be a global. Okay, it has to be a global. And we are writing as global, and usually when you write the operators global, you make them your friends, okay? Even if you are using the public interface in these functions, you make them your friends so that the reader can see that these two operators are defined somewhere, right? When the user studies our interface class interface, when he or she sees that the operator insert and operator extract are defined as a global function as friends, then they would know that they are available. So we make them friends. Okay, so let's look at the implementation from the book. I guess this is it. No, that's not it. I think this is it. Okay, so our regular class, our 4 constructors, okay, and our nice getters for the get amount, get dollars, get cents, and I have friend global plus minus equality operators, and I have two global stream insertion and extraction functions. Okay, stream insertion takes one of stream reference and one constant money reference. Okay, stream insertion takes those, and stream extraction takes a non-const I stream and non-const money reference. Okay, so exactly the way that so it is not that easy to, it is not that difficult to write this. Just, I mean, whatever the class you are writing, it is exactly the same. All stream operator insertion, all stream and so you only this part changes the type of the object, and this part is the same as the class name. Yeah. So kind of, if you don't understand what this is, just memorize it. But of course you have to understand that. It is not that difficult to remember this stuff. And let's look at well, once we have implemented it, it works very nice. I just print out your amount. I just get your amount from the keyboard, and I print your amount to the screen. Your amount is etc. So I can do it cascaded printouts. Your amount and this, and my amount is this, and comparison, and this addition stuff, and see, I can do that very nicely. Okay, so let's get the implementation. Operator stream insertion. Okay, remember what we did? What we did before? We printed the dollar part. For the cents part, if it is less than 10, we put a 0 in front of it. So absolute dollars, amount dot dollars, amount is this. Since I'm a friend, I can have direct access to the private parts. My suggestion is, the book is showing you that this is a friend and it is able to access the private data parts. Even you don't do that, always do, okay, this, public interface. Okay, you might say that why? I mean, why are we making a function call? We discussed this many times before. Well, function call seems expensive, but compilers are smart enough to inline those kind of simple calls. So it is as simple as, line 58 and 59, their cost will be exactly the same in terms of CPU time when this code is optimally compiled using the -O flag. Okay, so prefer 58 over 59. Again, the same thing. I get the dollars part as an absolute value. Okay, if the dollars are or cents are less than 0, then I put a dollar minus. Otherwise, I would just dollar. Then I print the absolute dollars. If it's less than 10, then I would do this. This looks weird, right? This looks weird. We used to say C out stream insertion dollar. Now I am saying that output stream, but output stream is actually my C out now, because they sent me this object C out as a parameter. Now my output stream variable, okay, is a reference to C out object. My output stream variable is a reference to C out object. Okay, whatever I make a change, whatever I do with the output stream, I am doing it on the C out actually. I am doing it on C out. Question for you: if I write this, would this work? Line 62. I change it from output stream to C out. It works, it compiles, it kind of works, but then why don't we write it? I mean, if this works, why did we set this as a parameter to this function? That's one thing. So it must be useful for something, right? So we are hurting something, and In this program, there won't be any change. It will, let me compile and run this, execute, compile and run. I hope I didn't change anything in this one. Yeah, compile, enter amount of money, $10.20. Okay, what? No dollar sign in money input. What does this program do? I don't know what this program does. Okay, enter the amount of money or amount, oh, it says I should enter, I don't know what, okay, dollar sign, okay, so I need to put this dollar sign, otherwise it is not happy. Okay, but finding the dollar sign is not that easy on my keyboard. Okay. Where did it go? Didn't I compile and run? Okay. Find okay, found it in the first try. $10.20. Okay, it says your amount is 10.20. My amount is 10.9. Okay, one of us reaches, etc., etc. Let me go back. Okay, let me change this to Cout. Okay, and do the same thing again, compile and run. $20.21 works exactly the same. So why are we doing this? Why are we using output stream instead of Cout here? What is the use?
We may want to use different output stream objects.
Are you talking?
Yes.
Yeah.
We may want to use different output streams.
Exactly. So did you hear what our classmate says? He said that maybe instead of Cout, maybe I want to use some other output stream objects. For example, what? For example, OF stream, okay, my file, and I'm going to make a file output.txt. This is now my output stream, okay, new output stream. Whatever I put into file, it will go to this output.txt. And instead of Cout, I am going to write file here, right? And file, and file. Okay. So my objects know how to write themselves to the file, not the standard output, but the file. Okay. So you did this like that, right? In your homeworks, when you open files, when you write to them. Okay. This is what you need to do. So if I use Cout in my implementation of stream insertion, then this file will be ignored, right? It will be written to the standard output, whatever parameter you send it here. Okay, good. Let me put that back in. I don't need this, yeah. Okay. So, good. Any questions on this? So, this is how the stream insertion works, stream extraction. Very simple, very simple. Okay, again, an input stream and money. This time we are going to change money object. Okay, first from the input stream I get a dollar sign. If the dollar sign is not dollars, though, I terminate my program like I did before. Okay, then I get the money as a double. Okay, I get a double, and I get its dollars part, but now this part is nice. See, dollars part and the cents part are private functions of class money. Since I am a friend, okay, I am a friend of this class, it is okay for me to call them. I am able to do it. So I call this dollars part and cents part, I get them, okay, and I assign them to the amount. Well, instead of this assignment, maybe I should have used setters, right? But I think we don't have the setters in this case because they eliminated it to save some space maybe. Okay? Good. Any questions about stream insertion and extraction operators? I didn't say anything new about operator overloading. I just said that, okay, this is a technique, this is a way of overloading these two operators. We should be careful because, I mean, it is up to me what I can overload the stream insertion and extraction operator like an addition operation. When you do the M1, I can do, it is easy for me to write this kind of a stupid, well, this is not stupid, but this one will be stupid. I don't know what's the meaning of this M1 stream insertion 2. Well, I mean, I implemented, or I could do 2 M1, and inside this one, I don't know, maybe I am just printing hello world. It's okay for me. So as long as I follow the syntax of the C, this one will compile, this one will compile, and this one will compile if I overload them properly. But don't do this, okay? Don't do this or don't do that. The proper way of overloading these operators are these, okay? So using the rules that we already know, we just looked at the details of overloading of these operators. Good. Okay, what is the time? I have 2 more, okay, good. I have 2 more minutes, and I am going to start looking at, okay, we already looked at this one. I am going to start looking at another operator that we need to be careful about, assignment operator. Remember, assignment operator has to be overloaded as a member function. What were the others? Assignment operator, okay, index operator, function call operator, and I think it was arrow operator too. Okay, we didn't look at the arrow operator, but these are the assignment operator, index operator, function call operator. These all have to be overloaded as member functions, okay? But I think I said it yesterday, assignment operators are automatically overloaded for you by default. There is a default assignment operator, and it's called member-wise copy assignment operator or default assignment operator. All it does is, for example, our money function, okay? All it does is, it takes the right-handed side, it takes the dollars part, and it assigns to the dollars part of the left-hand side. And it does the same thing for the cents part. So it is called member-wise copy. This assignment operator, the default one, okay, call the assignment operators of each of the members, okay, each of the members. So that's how it behaves. So that's why we don't overload them, because most of the time it works for us. But there are some cases, this behavior is not acceptable. Member-wise copy is something harmful sometimes, and sometimes it is not preferred because it is inefficient. In those cases, we need to overload this assignment operator. If I want to write this member-wise, okay, so let me try to, okay, so operator assignment, okay, it will take what? What does it take? It will take a money object, yes. Since I am taking an object, maybe I should take it as a reference, if I can find the, yeah, okay. So this is other. Is this a const function or not? Is the assignment a const? It is not const because I am going to modify myself. I am doing the assignment, right? So, but I am not going to change the other function, other object. So this is how it should be. Okay, this is how it should be, and I should return what? What should I return from the assignment operator? Void? No. If I return a void, okay, then I can't do this, right? Remember, this one is going to be done first, right to left. This one should return something so that I can continue with the other part here. So what should I return? What should I return?
Money.
Go away. What's going on? Just go away. Doesn't go away? Kill you. Okay. So you should return the money, right? So that I can continue. But maybe I should be more careful here when I am going to return myself actually, whatever I have assigned. Maybe I should return the money as a reference so that there is no copying involved. So this is how the header of the function operator assignment should look like. And if we implement this, let's implement this. Okay, of course I need to put this thing here, and yeah, so what am I going to do now? I will say my sense part will be the same as other dot sense part. Okay. What? Why? Is this a function? What is my sense part? Dollars and cents. Okay, sorry. Dollars. Okay, my cents will be other dot cents, and my dollars will be other dot dollars. Okay, so that's it. Should I do a validity check? For example, cents cannot be larger than 100, and if cents is smaller than 0, dollars should be smaller than 0. Should I do those checks here? Would it be a smart thing to do? In constructors we did that, right? In constructors we make sure that where is my constructor? Let me go to the constructor. Okay, constructor, yeah, I get this. Yeah, where is my constructor? Okay, cents. In constructors we say that the cents should be, okay, cents, if the dollars and cents are not in the same sign, then no, this is not consistent kind of thing, right? So I did this check. Should I do this check now while I am doing this assignment? Okay, you think about this, and when we come back we will try to answer it together. So let's be here around 9:35. Should we validate the values? Okay, that's the question. Okay, 10 minutes. 15 minutes, sorry.
Tier dostu.
Efendim?
Tier.
Anlamadım.
Tier mi bu?
Şey var, object oriented var. Diğer şeyde, Z23'te. Böyle düşünüyorum.
Başlasın ama ya gerçek gömlekleri falan filan. Pideli falan çekilmiş.
Sınıfta geliyorum hatta çünkü notlar açık demiş. Bilgisayarı açık izin verecek mi? Notlar açık demiş. Ben bilgisayar açık olursa daha iyi olur. Çünkü not yok. Yani bütün notlar bilgisayarda. O yüzden uzaktan bir görüşüyorum.
So the question is, should we validate the input? So what's your answer? Should we validate the assignment? Okay, this other dot cents and dollars should be less than zero, both of them, or should be greater than zero at the same time? Should we validate them?
We don't need to validate them.
Are you talking? So
Yeah,
what?
We don't need to validate them.
We don't have to validate it. Why? Because we know that other is a money object already. It should be valid, right? What is our rule in object-oriented programming? There are no objects with invalid data, right? Money is another object, and it's a money object. It has to be created using either a constructor or a setter function or anything. No one has access to the private data other than us. Okay, we did everything right. So money or the other money object should be a valid object. So that's why I don't have to validate our cents and dollars part. Okay. So nice thing about object-oriented programming. If we didn't do the encapsulation and information hiding, okay, principle of least privilege, then we never knew that the other money object is a valid object. Right? In this case, I know. If it doesn't include, if this money object, other object, doesn't include a valid data set in it, okay, then I did something wrong. My program is wrong. I had to fix it. So no validation here. Yes.
I think this is the Monday's attendance.
Wrong date? Really? So just turn it around. Yeah. Let's take the. So did I take yesterday's stuff or Monday's? What?
Mondays.
Okay, sorry. So let's take the classical. So any questions on this?
Okay, I have a question.
Yeah.
We mentioned the class name of the operator of the operator of the assignment.
Yeah.
We mentioned the class name, but could you please go up?
Well, this is not yet complete yet. I didn't return anything yet, but.
Okay. Oh, sorry, down. I'm sorry. But on the operator stream insertion.
Yeah.
Yeah, we don't mention the class name.
This is a global function. This is a member function.
Okay.
See, this is a member function.
Yeah.
So it takes just a single parameter. It's a binary operator, right? It needs two parameters. One of the parameters is myself, the other one is the other, okay? This one, these are all global function overloads. That's why they are friends. That's why they take two parameters.
Okay.
Got it?
I got it.
Okay. So that's something, actually, what you're asking is a very basic question, actually. And once you realize that, okay, well, that was it, it becomes kind of, it sounds simple, but these kind of things happen. I mean, when you first see them, why don't we mention the binary scope resolution operator money here? I'm sure I will, I mean, next week when I ask this question, I'm sure like 10% or 15% of the class will forget about putting this money here, or they will put money in here and that kind of stuff. That's because if you don't practice it, if you don't write it yourself, this will happen. And I suggest, this is a very simple program, right? Just 200 lines of code. Write it yourself without looking at anywhere, okay? Without getting the help from the compiler. Write it on the paper, because that's what you're going to do in the midterm exam. And you will see that you don't remember what I told you during the classes. These kind of things are learned, okay? These kind of things are learned by practicing, okay? Remember the cartoon that I showed you, okay? What did the cook Hoca said? Always learn by eating, not by memorizing. Okay, so what should I return now? What should I return? I could return, maybe return other. Yeah, that's good, right? Because if I return the other, I am doing the assignment from other to myself. Whoever gets this other as a reference, it will do the same assignment, right? So this is good. And sometimes, since we did not talk about this much, but remember this pointer, this is a pointer to my object, and we can do this. So I am pointing to myself with this pointer, and they're referencing it, I am returning a reference to myself. So I am returning myself here, or you could return other, because other will not be modified. Okay, and in fact, actually, this would be a better operator overload than the non-const one, because you are not supposed to modify. You are not supposed to modify whatever is returned, right? So let's make this const. For const is a better. Okay, good. Because I cannot return. See, if I don't make this const, that is it. If I don't make this const, I cannot return other. Other is a const money reference, right? I cannot return other. So let's make this const money reference, and I can return other, and I should be fine. So assignment is as simple as this, but I don't have to overload this. Why? Because this is already overloaded exactly as it is, exactly like this. This is already overloaded for you exactly as it is. So the default meaning of assignment operator is, okay, call the assignment operator between the members of other object and my object, one by one, okay? Call it one by one, assignment operator, 1, 2, 3, whatever, how many data members I have, I will do that. Okay, you have a question down there? No? Okay, any questions from the audience? Online audience? I think I'm going to. This one doesn't work that way. There is too much noise coming from to the microphone. This is messing up. I used to have a nice microphone that I had spent lots of money on it. Where is it? Can I find it? It was the pre-virus days. I will find it. Okay, I will find that microphone, I will use it. Okay, any questions from the online audience? No? Okay.
Yes, I'd like to ask a question.
Okay, somebody has a question, but your voice is so weak. Please speak up or come closer or whatever. Okay, ask your question.
You call instances as objects. May I ask why? I mean, they are not declared instances as objects.
Yes, instances are objects, yes.
Oh, okay. They're the same thing.
Yeah. What's an instance? Instance is a, okay. If we talk about the instances, okay, human is a class, okay. Ali is just an instance of this human class, or an object of this human class, or a sample of a human class, okay. That's what we call them, okay. When you say I have a human class and Ali is just an object of it, it's the same as I have a money class and M1 is an object of this money class, or M1 is an instance of money class or a sample of money class. And there might be some other terms that I forget to mention now, but I mean this is regular English usage. Okay? Or a copy, sometimes we call it copy of that class. But copy, since it has a different meaning in computer science, we don't use it that much, but sometimes it is used too. Okay? So the assignment operator is this. For now, we didn't have any need for assignment overloading the assignment operator. Okay? So we will leave it as it is. Okay, thank you. We will leave it as it is. Because the default assignment operator is fine for us. Remember, there was a default constructor too, and we didn't like the default constructor because it left everything uninitialized. I mean, the default constructor behaves like default assignment. Default constructor calls all the default constructors of the members in your class, okay? It calls all the default constructors of your member class, or no parameter constructors of your member class. But what is the no parameter constructor for the integer? It doesn't do anything, right? It doesn't initialize anything. So we don't like the default constructor behavior many times. That's why we provide a constructor for our classes. That's why we are writing it. Assignment operators, for now, it should be fine for us most of the time. But if we have a pointer in our class, usually we will have to write our assignment operator because let's say I have two objects. It has integers in it. Let's say 120 and 132 integers, and a pointer. And pointer is pointing to some place like that. Okay. Another object. Let's say I am copying this object 1 and object 2. Let's say I'm copying these three fields from object 1 to object 2, assignment operator. I copied 120 here. I copied 130 here. Let's say the value here is 0xF21. So, and I copied. I can't do that. Okay. So this is 0xF21. What does that make? Okay, it makes that both of them point in the same place. Very dangerous thing, right? If you keep copying those pointers like that, that's called shallow copying. Shallow copying is shallow as opposed to deep copy. Shallow copying is what the default assignment does, okay? Is a bad thing if there are pointers involved. So that's why, what do we need to do? we need to write our assignment operator, okay? Copy these two integers as it is, very nice. When it comes to the pointers, follow the pointer, copy this part exclusively by yourself, explicitly yourself. Okay, so we are going to talk about that when we talk about the pointers. Good. Okay, so assignment operator for now, we won't overload it much if we don't have to. Good. Let me move on. Another kind of tricky point with the operator overloading is the increment and decrement operators. You might think that what is different about the increment and decrement operators? They are unary operators, and we have overloaded the unary minus for the money class. We could have said money 2 minus M2. That's fine. It works, right? It works, yeah. We can do the same thing, but the thing is this. Okay, when I say minus M, the compiler will say it is either operator minus M or M dot operator minus, right? How about this one, plus plus M? The compiler will think operator plus plus M or M dot operator plus plus. How about M plus plus? The compiler will think operator plus plus M or M dot operator plus plus. So it turns out that, okay, this part and this part are exactly the same. I mean, how am I gonna make a difference between this pre-increment and post-increment? These are two different operators. Okay, their behavior, well, at the end, you end up incrementing M by 1, if M is of course, if M is an integer. You end up incrementing M by 1, but the value they return is different. They are different operators. But looking at the syntax, I don't see it. How am I going to tell the compiler that I am overloading pre-increment or I am overloading post-increment? How am I going to do that? So they found the solution. They said that, okay, to distinguish from this one, okay, to distinguish in overload, the standard overload method is the prefix. So if you do this, that means it is the prefix overloading of the operator plus plus, okay? Standard is this one. How about, am I not going to overload the postfix notation? Yes, you will. For that one, okay, we add a pseudo parameter, okay? Just a dummy parameter, add a second parameter of type integer for the postfix. So for the postfix one, the compiler says that whenever I see this, I will call this one, comma, 1, or I will call this one. So it feels like a binary operator, even though there is no integers involved in it, okay? It just adds this integer at the end of the parameter list so that it can distinguish from the post, okay? So just a trick from the compiler's part. So if you are overloading this one, okay, then use the standard one, prefix, postfix, you need to add this integer at the end. So it, even though both of them are unary, so we will treat the M++ as binary, okay? So let's see one example here from the book, okay, from the book. Let me go to the book, and I think this was our final example. Okay, good. So I have an integer pair like the character pair. I have integer pair now, first and second, my constructor, and I don't have a no parameter constructor. So I won't be able to make an array of this. I won't be able to. Can I do this? Let me show you this one. Well, I mean, you should have, okay, if I say in pair, and I like to make an array of this in pair, if I can find, okay, 100. Array of int pair of size 100, I will get an error message. What do you think the error message will be? Tell me the error message. The error message will be at this line. It says, what does it say? No matching function to call to int pair. So there is no constructor that doesn't take any parameters, right? We don't have a constructor like that. We don't have a constructor like that because I didn't write any. You might say that what happened to my default constructor? It is gone. Why? Because I have implemented this one. If I take this out, of course this line will compile, but now the line 23 will not compile. Okay, one smart thing might be this. How about this one? 1 and 1. Would this compile now?
23 will give an error, maybe.
23 will be an error.
This is the default for not.
Why would 23 be an error? I am
It's
providing
some
two
kind of
parameters
no-
and two parameters are here.
This is some kind no problem. No, sorry.
Okay, this will compile nicely, no problems. Because now I have a constructor that takes 0 parameters, another constructor that takes 1 parameter, another constructor that takes 2 parameters. It seems that way. Okay, so this one will work. Okay, good. So this constructor will take 2 parameters, and as you see, I have implemented 2 increment operator, prefix and postfix. What is the meaning of increment for such an integer pair? How would you do it? You would increment the first and second at the same time, or increment first? I think I would increment both of them at the same time. So I don't know how they did it, but okay. There's the setters for the first and the second, and these are the getters. Okay, it's so nice. Set first, set second. Okay, good. And let's look at the main function. Okay, a dot get first. This will print 1. Okay, and 2. And then I will do a plus plus b assignment b. B, I don't know. I mean, so this will print 1 and 2. How about this one? Assume that plus plus increments both the first part and the second part. I think this will print what? Line 28 will print. Let's go to line 30. Line 30 will print what? It will print what?
The increment value of a.
So what does it print? Just don't give me a philosophical answer. Just give me numbers. 2 and 3, right? It will print 2 and 3. Line 30 will print 2 and 3. How about line 28?
1 and 2.
It will be 1 and 2 because it is supposed to assign the unincremented, the original version of A, right? So that's what's going to do. And I am going to do the same thing here. A is an integer pair, the same thing again. This one will print 1 and 2. This time C is going to be incremented version 2 and 3, and this is 2 and 3, right? Okay, so I guess that's the results are. Let's look at the implementation of the. Better yet, let's implement them together. Okay, let's implement them together without looking at the code. You always do this, okay? Don't look at the code. Implement it yourself. Get rid of this stuff. put it in here. And what is missing here? Okay, in pair. Okay, and in pair. Okay, so this is our so why doesn't it close my curly braces now? So this is the prefix version. What does that mean, prefix version? It will increment my object first, okay? It will definitely we are going to increment the object first. That's the definition, right? So let's increment the objects, okay? So first plus plus, come on, first plus plus, second plus plus, and return this. Okay, I'm just returning myself. That's it. I incremented myself and I am returning myself. That's it. And let's copy this part. Let's copy this part and put it in here. This is the postfix version. If I do this exactly the same, that doesn't work, okay? The first plus plus and second plus plus should stay as before, right? It should stay as before. Maybe I should do this. Let's look at this one. So suggest me a way, okay? This one will go. First plus plus and second plus plus will stay because I know that I will have to increment them at some place. So what am I going to return? Something. Return a temporary object. Yeah. Return a temporary in pair. What that temporary object should be? Maybe it should be an int pair temporary object, and that temporary object should be exactly the same as my object. So this. So I am taking a copy of myself. After taking the copy, okay, I increment first and second, but I return the previous version of myself. Okay. So one thing is I can return this one as a reference, no problem, right? But I cannot return this as a reference. You understand this? I can do this as a reference. Why? Because I am returning myself, and after returning myself, I will be alive. But this one will go away. I cannot return a reference. That's why these kind of stuff are implemented that way. So prefix notation, okay, sorry, postfix notation returns a value, not a reference. But the prefix version will return the original object, and it will be done that way. Okay. So their associativity is their presence is the same. Okay. Some people remember what we discussed at the beginning of the semester. We said that people think it. People say that when I write stuff like this, A gets the value of C plus plus minus D minus minus. They say that minus is done first, then C incremented, then D decremented. No, it is not true. C incremented first, D decremented, okay? Before the minus, definitely this plus plus and this minus minus is done, definitely. After the minus is done. But C plus plus returns the unincremented version. D minus minus returns the undecremented version. And after that, minus is done. Okay? Definitely plus plus and minus minus is done first. And you can understand what is happening by looking at this code actually. Okay, good. So let's look at the book's implementation. The book says that for the postfix, by the way, see this one, integer? It didn't bother giving it a name. It's nice, right? Should I give a name? Should I give a name to this parameter? If I give a name, I should give a name of dummy. It's a dummy parameter. It is not used for anything, just dummy. Or don't give it a name. So the reader would understand that it's not going to be used anywhere. Okay? Why would I define a parameter that is not going to be used anywhere in the function? It is used to make a difference between these two in the signature, okay? So their signatures are different, so compiler wouldn't think that they are the same function. Okay? And decrement is done that way. Okay, this is the postfix version, this is the prefix version. It looks like this book example, it returns two temporary objects, integer pair temp1, temp2, and first, second. This one takes a backup. In my case, what I did was, I didn't return anything new object. I returned myself, okay, without making a temporary object. And in fact, I did better than that. I returned a reference to myself. And of course, I need to change this too. Okay, so good. Okay, what else? Setters and getters are already there. Any questions? Let me go back to the slides and let's finish up this chapter. Index operator, we already did that, right? Remember the character pair, 1 and 2. That's the index operator. Usually index operators are used with what? It is used with arrays, right? If you are going to make a new vector class or array class, we are going to do that. Okay, we are going to use this index operator. Okay, we looked at the example and we discussed already this. These are two different functions. These signatures are different. These signatures are different. It's not because this part is different. Okay, these signatures are different. It is because this part is different. This part is different. Okay, because of the don't take this in. Because of this part is different. Okay, these signatures are different, and we did this with the index operator. Okay, so let's look at these functions. So we have things like I can return a value from a function. I can return a constant value. I can return a reference from a function. I can return a constant reference. Okay? So we should always be careful with these two, because if you are returning a reference, then make sure that the object that you are returning the reference to is going to stay alive. It will not die as soon as you are done with this function f. Okay, that's good. And this one is no exception. You might say that since this is a constant, nobody is going to modify it. That's okay as long as they access this object, and then if that object is dead, even though you are not changing it, you are accessing some place that doesn't belong to you, and you are in trouble. Okay, so always careful with these two. Okay, good. I think that was the end of the chapter. The whole thing started with this. Okay, we kept talking about this, nothing else. Sometimes we couldn't do this because the operator is not available for us to overload. Sometimes they told us do not overload those kind of operators. And sometimes we said that, unfortunately, this is the one that we prefer, but unfortunately, it is not always possible in the case of stream insertion. And sometimes this is advantages, okay? It has advantages in terms of explicit or implicit by default automatic type conversion. Sometimes we have to do that. Okay, that's why they have introduced the concept of bad concept of friends. Okay, we don't like friends. Some object-oriented programming languages, they don't define friends at all. They say that it shouldn't be part of an object-oriented programming language. And other than quite frankly, other than the operator overloads, there is always one way to avoid. There is always one way to avoid the friends. The operator overloads maybe is the only place that you have to definitely use the friends. Okay, if you don't do the operator overload, then don't use the friends anymore. And by the way, they have invented this reference stuff. While we have pointers are nice, right? I mean, we use them all the time, but well, they may not be easy to use. You have to be very careful about the safety of the pointers, but they are nice. I mean, we can get along with them. Why did they introduce references other than the pointers? It is because of this index operator. Okay. Without the references, I cannot write this. Without the references, I cannot overload this index operator. Okay. If you don't have the operator overloading, then you can live without the references very nicely. Well, life would be a little bit more difficult maybe. Newcomers will have more difficulty understanding the pointers and etc. But this is C, you know, I mean, this is not for kids, okay? This is for serious people, and you are serious people, I hope. And that's what the references and the operator overloading and these kind of rules are all about, okay? Good, I think that's it for today. On Monday, as I said, at 17:30 you will have your midterm exam, and you are responsible from all the subject that we covered in the classroom until the end of this chapter 8. That will include operator overloading. Every single line of text you need to know, whether I told you in the class or if I didn't told you. Okay, everything from chapter 0 to end of beginning of chapter 9. Okay, I will start talking about pointers on Monday. That subject will not be in the midterm. Okay, so study hard, write lots of programs first on the paper, then on the keyboard on the computer. Once you see that your program works, make changes to your program to try to understand what is going on. Try to guess if it's going to work. It's going to give you a compiler error or some logical error, etc. If you do this kind of a practice, and you should be fine. If you did your homeworks and if you listen to me, you should be fine in your homework, in your midterm exam. Okay. Okay, I will see you on Monday morning then.